This is a generator designed by Tesla over 100 years ago. Interestingly, it caused an earthquake, forcing the experiment to be halted. How did Nikola Tesla achieve this? This is actually a net-attached generator, different from a rotary generator. According to Faraday's law of electromagnetic induction, a conductor moving through a magnetic field generates an electromotive force, creating an induced current. Tesla replaced the permanent magnet with an electromagnet and wound a copper coil around the end of the net-attached steam engine's piston rod. Next, let's look at the working principle of the steam engine. First, high temperature, high-pressure steam enters from the right end. The slide valve and piston inside move up and down under the steam pressure. Tesla then simplified it by converting the slide valve into a valve, forming two L-shaped hollow channels. When high-pressure steam enters the top of the cylinder from the left side, it forces the piston downward. Then, the right side connects, and the steam reaching the bottom forces the piston upward. Two exhaust pipes were added on each side, ultimately causing the steam engine piston to move upward. The greater the steam pressure, the faster the piston reciprocates. But Tesla was not satisfied. He wanted the piston to maintain a constant frequency regardless of steam pressure changes. So, he connected a sealed air spring system to the steam engine. The principle is simple. If the piston compresses the air inside, removing the external force will cause the air to bounce the piston back like a spring, oscillating at a constant frequency. The steam engine then operates at the natural frequency of the air spring system. In reality, the force acting on the piston is intermittent. The input of high-pressure steam is interrupted for a short period, similar to pushing a pendulum with both hands. Slightly increasing the force keeps the frequency constant, but the amplitude increases. Similarly, the greater the steam pressure, the greater the amplitude, but the piston oscillation period or frequency remains unchanged. Ultimately, the entire system operates at the same frequency, outputting alternating current at a constant frequency. However, during Tesla's experiment, a 7-story building shook like an earthquake. The vibration frequency of the steam-powered device matched the natural frequency of the 7-story building, causing resonance and triggering the earthquake. For safety reasons, the research had to be abandoned. In contrast, rotary generators are less complex and more reliable. Tesla's generator was eventually phased out, but its principles can be applied to geodynamics research. Any invention that benefits humanity is great. Like and follow for more informative videos.